Okay, 3.6, critical points and extrema. We have three different types of critical points that we're going to talk about, two of which are considered to be extrema. Okay, the first we're going to discuss is a maximum. Maximum is the point where increasing changes to decreasing. Now that's two concepts that we just talked about in section 3.5. So let's look at an example here. Just going to draw a picture. Here's a parabola, okay? And it's increasing. It's going up to a specific point. And that specific point we call a max. And then it starts to decrease. So, when the increasing changes to decreasing, that very specific point where it changes is called a maximum. Okay, and there's two different types of maximums. There's an absolute, and there's a local or relative max. I refer to it as a local max. Okay? An absolute max is simply the very highest point on the graph. So, highest point on the graph. To be an absolute max, it has to be higher than all points on the graph. Every single one. Okay? Not just the highest maximum. Okay, now this max that we have over here to the left is an absolute. There is no part of the graph that could possibly ever get higher than that. Okay? The local max would just be all other maximums. Okay, any maximum that's occurring that is not the absolute. We have the same thing basically with a minimum. Now the minimum is the point where it goes, where decreasing changes to increasing. So again, I'm going to use parabola as the example. From left to right, it's decreasing. To what point? To this point. And then at that point, it starts to go up again. It starts to increase. That point is a minimum. And if we refer back to the last max, we can actually say it's an absolute minimum. Okay? Absolute minimum the lowest point on the graph. The absolute lowest. Nothing else is lower. And then all others are considered local or relative minimums. There are other points that are lower than that min, but it's a local one. And you'll see in an example here, if we have like a cubic or some higher power that would cause more than one min to occur or more than one max to occur, you'll see what a local max or min looks like. And the last critical point is called an inflection point. This is more of a calculus term, okay? An inflection point. That's the point where concavity changes. Okay, what's concavity? Let me try to show you here. All right, I'm going to use a very simple y equals x cubed. Okay, nothing special here, just a plain y equals x cubed. Now, part of this graph we're going to consider to be concave up, and the other part is going to be considered to be concave down. Now, at some point in time, okay, about right here, okay, the top part of this is curved, okay? What direction is the curve opening to? It's opening up. So curved up means concave up. Okay, the graph is curved and it's opening up. That's concave up. This part of the graph down here is curved, but it's opening which way? Down. So that's considered concave down, or curved downwards. When it switches from concave up to concave down, or the opposite, concave down to concave up, then we have what's called an inflection point. Okay, this point where it changes concavity. That's your inflection point. Now, at this point in time, we really can't solve for these. All I'm going to have you do, especially the inflection point, I'm just going to have you identify them. Now, max and mins, we can use a calculator to do it, but without calculus, okay, without the exact science of calculus, we cannot find max and mins and inflection points by hand. But as soon as you know how to do what's called a derivative, you can do that in calculus. Okay, the first derivative equal to 0 will find maximums and minimums. The second derivative equal to 0 will tell you where the inflection points are. So we got to get the calculus before we can do that by hand. Today we're going to simply look at some pictures, determine what they are, and use the calculator to find max and mins, because that will do it for us. All right, so let's look at our first example. Identify the extrema for f of x. So here is a picture. We need to find out what's happening at these specific points. Okay, we have -3, -1. Looks like a specific point. 1, 5 is a specific point. And then 4, -4 looks like a specific point. So let's talk about these. -3, -1. If we're talking about increasing and decreasing, looks like to me the graph is decreasing. And then it looks like to me the graph is now increasing. So what occurs when it switches from decreasing to increasing? Basically, I think you can look at it and just say it is a minimum. Now, is that the absolute lowest point? No. So that is a local min at -3, -1. All right, now we're going from increasing to decreasing. So that causes a max. Now, is that the absolute highest point on the graph? The answer is no. Even though it's the only maximum, there is graph that is still going higher. Okay, so it's not the absolute maximum point on the graph. It's simply just a local max. And that's occurring at 1, 5. And then again, we're decreasing and switching to increasing. So we have another minimum. This one, though, is the absolute lowest point. There's nothing else lower, so we're going to call that the absolute min at 4, -4. So if we give you a picture with some specific points on it, you should be able to tell us whether it's a max, a min, absolute max, local min. All of those you should be able to identify. Okay, next example. Identify the extrema for this function. The function is f of x equals 5x cubed minus 10x squared minus 20x plus 7. Now, extrema refers to max and mins. Again, I'd have to be very specific about the inflection points. We're going to find the max and mins using a calculator. At this point in time, we can't do that with a calculator. So, max and mins, Extrema. Okay? Only the Extrema. We're not going to look for any inflection points. So, let's type in the graph. 5x to the third minus 10x squared minus 20x plus 7. Start with a zoom 6, standard zoom. That way everybody's on the same page. Now, I can't see the entire graph. It looks like the top part is cut off and the bottom part is cut off. So, I'm going to change the window. Top and bottom, high and low, is your Y min and your Y max. So, the Y min I'm going to make lower. I'm going to try negative 20 and positive 20. Just going to make it a little bit larger. Okay, so that works for the top. The top is good. We don't have to mess with the Y max anymore. But we still have to make the bottom larger. So, the Y min, I'm going to go ahead to negative 50. Okay, that works. If that didn't work, I was going to go to negative 100. You just keep doubling until I could see it. All right, so we definitely have a local, looks like to me, a local min and local max. I'm going to go ahead and change the window one more time. I'm going to make the x min and max 5 and negative 5, just so we can see a better picture of that curve. All right, if you look at my cursor here, looks like to me we have a local maximum here, a local minimum occurring here. We need to calculate those. If you hit second, trace, which is right beside the graph button, we have number 3 and 4, min and max. Min and max. I'm going to calculate the maximum. Now the question that it asks us is left bound. That's telling you to put the cursor, the little blinking X, to the left of your maximum. Anywhere to the left. Now, you don't want to go too far, okay, but you don't want to be too close to it either. You definitely want to be left of it and press enter. And then it says right bound. So you want to be right of that. So we go to the right, and enter. And then it asks us for a guess. You can put this anywhere. You can put the guess as close as you want. You can even type in an X value. So, what's it look like? I can't really tell. I'm just going to go ahead and hit enter and see what it says. Okay. So this is what we're getting. I'm seeing a local max at, looks like, negative 0.667 and 14.407. Now, calculator doesn't give you fractions. You could try to turn it into a fraction. Okay, this looks like negative 2/3 to me. 14.407 doesn't look so nice. Okay, how would you attempt to turn that into a fraction? Well, we go to the home screen, and we actually pull up the value of x. When you find the max or min, it stores the x coordinate to the x value, and it stores the y coordinate to the y value. So if I hit x, and then hit math, and then hit turn into a fraction, if it can, it will. In this case, it doesn't. Let's try y. Where is y? It's alpha number 1. A little hard to see on my calculator. Alpha number 1 is y. Math, fraction, and that one actually worked. Okay? Now, there is some rounding error with the calculators, so I'm going to go ahead and write negative 2/3 and 389 over 27. I actually worked this out using calculus, and I got the exact answer of negative 2/3. So, I'm going to have to check out why the calculator is slightly off. Again, it is a machine. It is rounding, the way they solve these. it actually uses approximations instead of the exact science of calculus. So if it doesn't work for you at this point in time, since you don't know calculus, I'll have to accept the decimal answer of negative 0.667 and 14.407. I cannot expect you to get negative 2/3 if the calculator won't give it to you at this point in time. But I do want you to try anyway. Try to turn it into a fraction. All right, let's get back to the graph. Again, we have a local minimum here, so I'm going to go ahead and calculate that. Second trace, number 3, minimum. So again, it says left bound. So I'm going to put the x to the left of where it looks like to me the minimum is. Hit enter. Now I'm going to put the x to the right. Hit enter, and then hit enter on the guess. All right, now this one's looking much better. Local min at, it looks like to me, 2, negative 33. Again, I actually calculated this. I know it's 2, negative 33. This rounds to 2. I couldn't mark it wrong if you put 2.000. Okay, so if you want to do that, that's fine. So we have a local min, local max. Again, there's no way of this. There's no calculation for an inflection point. So at this point in time, we're just going to look at the extrema. So we found them. There's a local max and a local min. Let's look at the next example. All right, now this one's a little different. This one wants you to identify the critical points of this function, 2x to the 5th minus 5x to the 4th minus 10x cubed, at very specific x values. So they want you to look at x equals negative 1, x equals 0, and x equals negative 3. Now, two things different. Last example asked us for extrema, telling us basically we're only looking for max and mins. This now says critical points, which means to me it's going to include an inflection point. Real good chance that one of these x values could be at an inflection point. So let's go ahead and get the calculator back out. Let's type in the function. 2x to the 5th minus 5x to the 4th minus 10x to the 3rd. And we always want to start at the same place. So we're going to go standard zoom, zoom 6. Okay. Looks like we have something very interesting going on here around the origin. Okay. Also down here, looks like we're losing part of our graph. So we're going to have to change the y minimum. Okay, so y min. I'm going to go ahead to negative, looks like to me it's pretty far down. So I'm going to go negative 50, which is not enough. I'm going to go ahead and double that to negative 100. Still not enough. I'm going to go ahead and double that. Y min of negative 200. Ah, there it is. Now, when we stretch this out, we can see the minimum. Okay, and I'm actually going to make it a little further. Let's go make it negative 250. We can see that minimum, but now we've lost everything up here. Can't really tell what's happening at the origin. So let's go ahead and calculate that minimum. Okay, so we want, there's the x, put it to the left, hit enter, put it to the right, hit enter, and hit enter on the guess. So we have a min, local min, at 3, negative 189. So there's our x equals 3. That's taken care of. So we know there is a local min at x equals 3. Specifically, 3, negative 189. It's local because there is graph over here, as you can see, going lower than that minimum. Very good. Let's go back to a zoom 6 now. So we want to look at that origin. We want to see what's happening right around there. So I'm going to zoom in on that. Zoom to. Enter, and then hit enter one more time. All right, very good. All right, it looks like we have a maximum. I lost a little bit. Missing it up here, so I'm going to make the window just a little bit larger. Maybe a 4. Whoop, hit the wrong one. That was the X max. I want to change that. I'm going to change the Y max to 4. There we go. All right, so we can see that max now. Let's calculate it. Second trace, maximum. Okay, let's get that X over there. To the left of that, enter. To the right, enter, and hit enter on the guess. Very good. Local max at -1, 3. All right, there's our -1. So we know what's happening at 3. We know what's happening at -1. Why is it local? Even though we can't see it, if we go back to a zoom 6, we have part of the graph over here that is going up forever. So it'll be going higher than that maximum point, so it's not absolute. All right, so we have a min, max. Let's see what's happening at 0. Let's go ahead and zoom in again. All right, let's make that even closer. Let me make this -1 to 1 and -1 to 1. Okay, right there at 0. What do we see happening here? Looks like the graph is curved. Flattens out and then it curves back down. So what is happening right there? Concavity is changing. It's going from concave up. This is curved upwards. It's opening up. Okay, it's opening upwards, concave up, to concave down. It's opening downwards. Okay, it's open down. That is an inflection point. At 0 what? Well, it looks like 0, 0, but we can tell for sure. We hit second trace and pick number 1, value. We can put in any X value. 0, it'll tell us exactly where it's at. 0, 0. We could have done the same thing with the max and mins, but you're not always going to get the X values, especially on the test. You're going to get an equation, you're going to graph it, and you're going to have to find the max and mins. If I want you to find an inflection point, I am going to have to tell you a specific X value. Okay, because at this point in time, we can only look for them. So local min, -189, local max, a -1,3, and an inflection point at 0, 0. Okay, I think that's it for today. Let me double check. That's it. That was our last example. So that's it for lesson 3.6.